Okay, let's start the session. Welcome to the fifth tutorial session of Operational Planning of Power Distribution Systems, whose instructor is Professor Sanjeev Gangle sir from IIT Guwahati, and I'm Satya Vikram from Department of Energy Science Engineering, IIT Bombay. And we will see the few of the problems related to this course that will help you to solve the fifth assignment. And in this, we will see the reliability questions. Firstly, why the reliability is actually important. Then the few of the terminologies like SAFI, DAFI, and based upon that, few small problems we will see. We will figure it out. What are the major important aspects which we have to see to solve the assignment? Okay. So without wasting time, let's move further to first reliability problem. So here it is a question. There will be few problems as that where the statement based problem will be there. Suppose I will give the four statement. You have to tell me that which statements is actually correct depending upon the definition of that particular aspect. Okay. So this problem which is in front of you actually this is related to the outages because when you have the interruption in the supply side then it will actually means related to the consumer behavior also that it will affect the demand side also. So sometimes whatever we do the intentional cut off of the supply, sometimes it is actually happen due to a fault. Okay. So the first statements here given with respect to the outages, you have to tell me that which statements are actually correct. Just try to solve, and if you face any problem, just let me know. Okay. Just read the statement. I will give the solution. Just read the statements first. Okay. Option B. I got one answer. Okay. Let's wait for one more minute. After that, I will give the solution. I request everyone to solve. Whoever have joined this tutorial session, I request them to solve because it will be more like a multi to one kind of interaction, so that I can help you to understand the concepts. Pankaj, if you wanted to give any answers. Okay, let me give. Let me give. Let just wait. See here. What is actually telling? Okay. So basically, the option which is correct. So the option define correct, correct. It always incorrect. It means that correct. It matches the definition. Okay. So 2, 3, 4 is correct. 2, 3, 4 means option B is correct. That's true. Okay. So when you see the first part, what it is a statement is stating an outage always result in interruption of supply. Okay, that is not actually correct. When we have seen the feeder structure, there we have seen the multi-generator kind of structure. When you could you please maximize your screen? Is it not visible? Anyone please confirm because it will not be. I will not able to write in on that on this. Okay, let me decrease this. Is it fine? Okay, is it fine now? Please confirm. Is it fine now?
Yes, sir.
Okay, okay. When we have seen the feeder structure, there was the means ki when you have the single feeder structures, there if it is connected to two substation, basically when you have when we have seen that let me erase it here. So when we have seen that the structure, when this was the one bus bar and it is connected to the same bus bar connected to the one isolating breaker is there in between. Okay, and there we have the loads which is connected to this. Suppose this is the one feeder structure is there. Okay, so suppose what happens that this generator goes into the outage condition. Okay, so it means that this source interruption happened. Okay, but this will not result in the outage of the supply. Okay, why? Because there is a second generator which can supply this load. Okay, so when you see from the when you can see from the distribution side, from the load perspective, your supply means it is not related, means you don't have seen the outages in this condition. Okay, because you were getting the continuous supply. It was whether from the double unit or whether from the single unit, whatever you were consuming at that particular time frame. Okay, suppose you were consuming 3 kilowatt when the one inverter was there, and it suddenly one got tripped out, the second was actually supplying the power, so you will see other instance although 3 kilowatt you are consuming. Okay, so that first statement is actually false. Second statement, if when you see the an outage refer to the non-ability of the operation of certain equipment, that is true because this equipment which is went into the outages condition, this equipment is not in the operational condition, or you can say it is not available to supply any kind of load. Okay, in this case of generator. Okay, so that is actually correct. Third, it is given that a forced outage occurred due to the emergency condition. That is true. Why? Because suppose the one generator got tripped and it was in the outage condition. Second was operating, but suppose it's a maximum capacity is 30 kV or 30 kilowatt it can supply at a time. Okay, but the load when you see it was 60 kilowatt which got distributed 30 and this was 30. So it was at a instant of time it was supplying the 60 kilowatt of load. But what happened? One went into the outage. So in this kind of situation, the emergency condition will be there because now the demand is 60 kilowatt, but the generation is 30 kilowatt. Okay, so this is a kind of generation is not actually equal to the demand. In this condition, either you switch off the few of the loads if you have the capability, means certain feeder you can opt out with this breaker, just strip out this leg and keep supplying the 30 kilowatt. Okay, but in the emergency condition you can do the force outages. That is true. A scheduled outage is carried out for preventing maintenance. That is true because sometimes what happens that some fault came and you have to uh, uh, do the maintenance in that feeder or in that line. So you have to do the scheduled outage condition. You have to see in the certain years that and in certain months that your system is actually working fine, which is being desired. Okay, so the option B is actually correct. Okay, here also what I have wrote in this also you can see the if one transformer is out but the low voltage transfer another transformer, that is incorrect. So first statement, so outage is not ability of the operation of certain equipment, that is true. And the force outage equipment taken out of service in the emergency basis during the sudden fault, overheating, installation failure or protection trip. Okay, and the fourth statement was that ki equipment taken out of service for the preventive maintenance, that is planned in advance, that is being given to the load side, that is a consumer, that ki this time frame the service will not be available. Okay, let's move to the second question. Try to solve this. Here the four options, four things are given. There is a force outage, schedule outage, partial outage. I think the two is given. Okay. So you have to tell me that which is actually correct, which is matched correctly. Suppose the A correctly matched, B correctly matched, C correctly matched, or D correctly matched. Okay. Multiple answers can be true. Okay. I got one answer. Let's wait for others also to give the answer. Okay, I got one more answer. Option C. Okay. B and C. Okay. Let me give the answer in this. So when you see here what is given that force outage. What is actually means by the force outage means? Force outage means let's understand with the example. Suppose we have two generator that we have already seen the example, and you have the second generator means G1 and G2. Okay. What happens that ki G1 went into the off condition due to some kind of fault. Okay. In that situation, G2 is operational. G2 is on. Okay. And there are multiple load which is connected. Okay. And that we have already taken example 30 kilowatt and 30 kilowatt. And the load is actually 60 kilowatt at a point of time. Okay. In this situation, yeah, the load is not able to supply the overall system. In that case condition, you can do the force outage. Okay. But it is not due to the maintenance. Okay. It is due to the some outage condition of particular generator. Okay. So the option A, when you see, it is not correct. It is whatever the definition it is given, equipment taken out of service or preventive maintenance, that is called as scheduled outage. Okay. So the second option, when you see the second scheduled outage, equipment taken out of service on emergency basis, no, this is false because it is taken out not on the emergency basis. They are priorly being scheduled that this time frame, this generator will not be operational and load should not be provided. Means service cannot be provided in that time frame. Okay, that is called as scheduled outage. When you see the partial outage, equipment operational with the reduced capacity, that is true. Means because when you have the suppose this 30 kilowatt generator went into the off condition, this G2 will can supply the 30 kilowatt at a time. So what you do, you simply switch off this circuit breaker and it can supply the 30 kilowatt at a time. Okay. How you should know that ki this is actually 30 kilowatt it is being supplying? You already know the meter which you have installed. Okay. So meter actually installed on the basis of capacity, what power you are going to consume. Suppose 6 kilowatt, 5 kilowatt, 10 kilowatt. Okay. So on the basis of that, you know that what is the connected load in that house. And also you know the in that particular feeder what is the daily load curve. Okay. So that you can at it at particular time frame what the power will be consumed, you already know. Okay, from the previous data analysis. Okay. And the partial outage is not the complete shutdown. Okay, so the option C is actually correct. Okay. So here also I wrote force outage, that is false because it is preventive maintenance. It is actually correct, incorrect. So the preventive maintenance is planned, that is scheduled outage, not forced. And also scheduled outage is on the it is not on the emergency basis. Emergency basis means unplanned immediate renewable. Okay. Removal. Partial outage operation with the reduced capacity. So option C is actually correct. Suppose the example already I wrote कि generated during due to the cooling issue, a transformer limited to the lower MVA. What we have already seen that 70 to 75% loading is preferable in the condition of the transformer. Okay. Suppose there is a 50 MVA transformer is there, so you do not go to the 70% times of 50 MVA. Okay, so that is actually required, so to protect it from the thermal damage. Okay, in that situation we actually reduce the load. In that case of reduced capacity operation is there. Partial outage is not complete shutdown, that is false. Okay, let's move to the next problem. This is related to the some information which is recommended to be included in the equipment outage report according to the IEEE committee guidelines. So what things to be included, okay, which is not included, that you have to tell. Okay, I got option B as answer. Okay, let's wait for others also to solve. Okay, option D, I got one more answer. Okay, option B, two answer, option D, one. Okay. Who have already given the answer, just verify whether it is correct or not. Whether option B is correct, option D is correct. Okay, let me give the answer. So, I think option B is correct because the only outage duration is not required. Time restoration is also important. Okay. So the first true. Okay. Option three is false. Okay. So the option B is actually correct. Okay. Because when you see, suppose you have a distribution system. Suppose this is a kind of distribution system you have, and you have generating unit somewhere, and this is the kind of line you have, and there is a multiple loads which is connected in that feeder. Okay, and this is connected to some generating unit far away. Okay, and this is the line which is having some RLC component, and this is the bus 1 and this is bus 2. Okay, so in this kind of system, in this kind of distribution feeder, you have lot of equipment which is being connected. Whether suppose you have connected a circuit breaker in case of the faulty situation to isolate the feeder. Okay, you also connected the transformer will be also there in between or somewhere. Okay, to reduce the power which is coming to voltage level which is coming to your distribution feeder. Suppose this is 230 volt and the generating unit is 1200, so in that sense you have the transformer also. Okay, so in that IEEE, as per the IEEE committee guidelines, so in equipment outage report when you make, there you have to tell the equipment type, design. Suppose the transformer is there, whether it is a star star connector, star delta connector, delta star connection is there. So you have to tell me the what is the design is there, who is the manufacturer, whether it is made by the Bosch or made by the some other company. Okay, or classification details also, whether it is a isolated transformer, whether it is a step up transformer, whether it is step down transformer. This classification detail also you have to give. Okay. Second, what you have to give the mode and cause of failure along with the environmental condition. What do you mean by environmental conditions? What was the temperature? What was the pressure in that situation? What you have to give. Okay. Sometimes what happens that lines also get very much heated up, and in that situation also some faults can be there. And we have already seen, suppose the rainy season is there. Okay, and there is a corona effect is there. Okay, in that sense also some kind of fault can come. Okay, insulation damage can happen. Okay, so in that situation sometimes the you have to tell what was the condition of the environment in the in which the failure comes. And in this, the when the outage came, you have to tell the restoration time as well. Okay, so that sees the how much reliable your system is. Okay, whatever the intended operation was scheduled to be there, and after the fault came, how much the system restored fastly, that actually define your reliability terms. Okay, so the option 3 is incorrect. Installation details, system location, outage classification. Okay, that also being you have to tell. Okay, you have to write. So in the equipment outage report, you have to tell the all the details of equipment, all the operational mode, environmental conditions, installation details, system location, equipment type, classification, design, manufacture, everything. Okay, that's all. Let's move to the next problem. Here it is written that you have to tell me the what are the major challenges in the distribution system reliability assessment. Okay, there are four options I have give, which is the more challenging part in the assessment of the certain distribution transformer distribution system reliability. Okay, I got one answer, option B. Okay, option B also, option B and option D. Any other answers? Okay, I got option D. Okay, let's read the statement first. What is the answer? Correct answer is option B is false. Option 2 is false, means option B is actually correct. Okay, let's read the statement. Okay, but it is written that what are the major challenges in the distribution system reliability assessment. Okay, so when you see the first part, it is written that lack of sufficient reliability performance data affect the assessment accuracy. That is true. When we have seen the IEEE guidelines of when you make the outage report, guidelines for making outage report, there sometimes happen that you don't know the equipment particularly written the when the time of outage, time of restoration. Okay, if these kind of data is actually missing, in that situation you cannot say that what are the accuracy, how the reliable your system is. Okay, sometimes you wrote that 5 minute the restoration happened. Okay, and but it happened in the 5 hours. Okay, that affects your accuracy of the assessment. Okay, so we then in that situation we will be in the assumption that it restored faster, but it appears to be slower. Okay, so that's things actually affect the reliability, performance, and means assessment accuracy. Okay, so that is also important. Second, it is written the most distribution interruption are unrelated to weather condition. That is false. Temperature, pressure, and everything other environmental conditions affect the humidity. Everything affect the distribution interruption. Okay, so it is incorrect to say that ki weather condition is not affecting the interruptions. That is false. Okay, so when you see the severe weather and inadequate maintenance are major cause of interruption, that is true. Okay, sometimes what happens, the you have the lot of rain in particular day, storm some particular day, that actually affect the reliability of your distribution feeder. Okay, in extreme situations. Fourth is timely identification responses to the failures improve the reliability. That already we know, that is true. Okay, so the option B is actually correct. Okay, let's move forward. Try to solve this problem. It is in all the four statement you have to tell which correctly describe a benefit of reliability based study in the power distribution system. Okay, A and B. I got one answer. Okay, option B. Okay, just wait for a few more seconds. Okay, option B. Option B, option A, B. Okay, just wait for a few more seconds after that. Okay, option B. Okay, option B. Okay, let me give the solution. So already all of you have responded. So that's good that your guys are actually reading the statements. So when you see the first option, it is it eliminates the need of system maintenance. Okay, that is false. In somewhat sense, why? Because the reliability based study in the power distribution system, that is important to reduce. So there will not be any system which is 100% uh, so much robust that it will not have any interruption, and it will eliminate anything. Okay, so the maintenance is already required. So what we do, you all have data, all the assessment data, then you see use some metric to quantify. Suppose you are using the SAFI or you are using the SADI, that we will see in the further class, further slide, and then you give the some kind of results and see some conclusion out of that. Okay, suppose in the conclusion you say that this transformer happens to get out fast. go into the outage fast. Okay. So this we know means that this transformer will glow in the outage, so you have to remove it. Okay, or you have to maintain frequently that. Okay, you have to check the oil frequently in that situation. Okay, so this kind of things will come into picture, but it will not eliminate the need of system maintenance. Okay, so the first statement is actually false. When you see the second, that it helps to quantify the impact of design improvement options. Okay, so when you see that is also true that design impact improvement options are also there, because when this data will go to the this transformer data go to the some OEM, okay, which make the transformers. Okay, so they already know which are the parameters. Suppose temperature is one of the factor affect the system reliability, so they try to improve and incorporate in the designing part. Okay, so that kind of helping that kind of assessment will help to quantify whether the which kind of parameter actually affecting that particular equipment in more sense. Okay, that B option is correct. Let's see the C option, that it guarantees zero outage in the situation system. That is false. Why? Zero is never been the correct way to demonstrate. You already do the study. You try to minimize the outages. Okay, but you cannot say that it will equal to zero. Okay, you cannot guarantee it. D option, when you see it, only focuses on cost reduction without a performance analysis. That is false. Okay, cost is one of the factor. Cost is one of the factor. Means maintenance cost you have to also reduce. When you do the predictive maintenance or preventive maintenance, you reduce the cost by means when your equipment went into failure, early duration of time, early life. So that is also incorporated lot of cost. So by the regular maintenance, you can reduce that cost. But only focusing on cost reduction, that is false. Okay, so the option B is the correct. Okay, so here we have already written. Okay, okay, so the option B is actually correct. Okay, it is written that reliability assessment help to evaluate the how design changes, redundancy, better protection, improvement, and everything. Okay, let's move further, try to solve this. So here the few problems in the series of these problems, that few questions will come on the basis of that distribution reliability matrices. Okay, whether SAFI, DAFI, and other matrices. So small problems to build the concept. Okay, try to solve this if you know already the what is actually the definition of SAFI, and otherwise I will give the answer in the few minutes. Try to solve this. Okay, option B, 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 I've got. So I got three answer. Okay, let's wait for a few more seconds. Okay, option B. Okay, just wait for 10 more seconds. After that, we will give the answer. Let's move to the answer part. When you see how there will be one distribution company, Discom will be there, okay, which supplies the total interruption per divided by total customer. Okay, let's see. So the SAFI definition is, SAFI is basically summation of Ni divided by summation of T. Okay, summation of Ni means summation sum of all the interruptions divided by total number of customers or consumers. Okay, so here when you see what are the three sustained interruption events are there, 600, 900, 300 is there. Okay, so when you see the customers which is there, so here when you see the 600, 900, 300 total interruption is there, so it will be 9, 6, 15, 3, 1800. Okay, so total number of interruptions are there is 1800 out of 12,000 customers. Okay, so it will be come out to be 0.15 interruptions per customer. Okay, so that is called as SAFI. But there is some kind of limitation in this. When you see the SAFI, so suppose the 12,000 out of 12,000 customers, 1800 interruptions were there. Okay, but it is not showing the bigger picture when it happened, how fast the system got reclosed, and how the system operation were there in that situation. So these kind of SAFI matrix is not capturing the overall system behavior. Okay, all the reliability terms which was important. Okay, also it is not quantifying the how the quantification was there. Suppose through this we can see that three sustained occurred affecting 600, 900, 300 customers. The quantification is there, 900 was more severe than as compared to the this was more severe than the 600 than 300. Okay, but what was the event? Okay, what was the event, and also how much weight was there? Okay, how much line got tripped? Okay, so that is not quantified in that. So SAFI is not that much important criteria to evaluate the reliability. Okay, that's why we went into the other reliability matrices. Okay, try to solve this very small problem just to give make you understand the that definition, and also to fit in your mind whether what is actually this terminology is. We will not waste time on that. Okay, option D I got 2 by 8, 1 by 4.25. Okay, check again. Okay, option C. Okay, option C, yes. Let's wait for 10 more seconds. Yes. So the option C is actually correct. That is true. Okay. We already know what is SAFI. SAFI is basically summation of Ni, total number of interruption divided by total number of customers. Sum of interruption is 1200 plus 800. Okay. Divided by 8000. Okay. That will give out to be 0.25. Okay. Interruptions per customer. Okay. But when you see the sustained or affecting 1200 customer, 800 customer, that is fine. Okay. So by definition, SAFI is this. Okay. Let's see some of the reverse way to see that. Try to solve this. Okay, option C. Okay. So the by definition, we already know the SAFI is actually equal to summation of Ni divided by Nt. Okay. So what is asking here? SAFI is already given zero point 0.3, Nt is already given 15,000. Summation of Ni will be equal to 4,500. Okay. So that is true. Other way around. Okay. Let's move forward. Try to solve this SADI. This is related to the SADI. Okay. Okay, I got one answer option C. Okay, two answers option C. Let's wait for others also. Okay, I got other answer option C. Okay, so I got multiple option C as answer. Okay, so let's see the solution. So here when you see the comparing with the SAFI was just a summation of Ni divided by Nt. Okay, here was the time was not there. Okay, interruption time, how much time it got interrupted. Okay, so but when you compare with the SADI, the by definition when you see here the summation of Ni Ri divided by Nt. Okay, so when you compare both, here also one time frame is also considered. Okay, so that is more means important to understand that how this reliability matrix is being involved. Okay, here the time frame interruption time is also being considered. Okay, so when you compare and try to solve for the SADI, here the 800 customers were there for 2 hour it got interrupted plus 500 for 3 hours. Okay, and also total when you see the 10,000 customers were there, when try to solve 800 multiplied by 2, 500 multiplied by 3 is there, and then divided by 10,000. Okay, when you try to solve it will come out to be 0.31 hour per customer. Okay, Ri is the restoration time, number of interrupted customer, Nt is the total customers. Okay, so it will come out to be 0.31 hour per customer. So when you see that for a single customer, okay, in a year, it got interruption of 0.31 hour out of 24 hours. Okay, not 24 hours means zero point 0.3 24 hours multiplied by 30 days, 1 day, and also when you see 365 days. Okay, so kind of, so when you see the 0.31 hour of interruption was there overall year. Okay, so that kind of quantification was there, so here the time frame is also being added. Okay, so that is more important. When SADI is more a realistic way to see that, and as compared to SAFI. Okay, let's move forward. Try to solve this problem. Okay, I got one answer, option C. Okay, 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 option C. So when you see here the option C, I got multiple option C's. So that is true. Like we know that what is the SAFI definition is there. SADI definition is there. That summation of NI RI divided by NT. Okay. So here the SADI is already given 1.2, and it is also given NT value is given. So the summation of NI RI will be there equal to 1.2 multiplied by 20,000. Okay, so it will come out to be 24,000. Okay, so customer out unit is very important. Okay, so when you see here the side is very important uh, uh, to see that when let's compare with the realistic scenario. Suppose I wanted to make a discom index of India. Okay, in that situation I have taken the all the states. Suppose I have taken the Uttar Pradesh, then Himachal Pradesh and Punjab, and all the states means कि Maharashtra and everything. Okay, then in that I made certain kind of performance indices to see that कि which state is performing better. In Uttar Pradesh, we have taken the UPPCL, some kind of one of the discom. In that, we have seen the what is the SADI is there, or Maharashtra, we have taken MSEDCL. So we see that what is the value of SADI. So its SADI came out to be here 1.2, here came out to be 2.4 somewhere. Okay. So in that performance indices with the some weight, we can say that this MSEDCL is performing poor as compared to the UPPCL. Okay, so these kind of reliability improvement means कि when you see the reliability reliability quantification is important to make a certain kind of index to compare the state discounts that which is actually performing at a what rate. Okay, so this kind of one of the conclusion you can draw from this. Let's move forward. This is somewhat related to the SIDI. This is a new kind of reliability matrix. SIDI. Try to solve this. Okay, option B. Okay, option B. Okay, option B. Okay, let's wait for 5-10 more seconds. Okay, option B. Okay, let's give the answer. So what we have seen, we have seen the SAFI. SAFI is basically equal to summation of NI divided by NT. Then we have seen the SADI. SADI is basically summation of NIRI divided by NT. Okay. Now, when the same one more terminology came from the SADI side, so it is basically the SADI divided by SAFI divided by SAFI. Okay, or you can say that summation of NIRI divided by summation of NI. Okay, so the unit will come into the hour, or you can say the time unit. Okay, so by the definition, when you go out, so SADI is already given that 1.5 and the SAFI is given 3, so it will come out to be zero point 0.5 hours. Okay, now there is a other way to see that. Okay, so let's see, suppose SADI is given in this problem is equal to 1.5 hour per customer. Okay, what does it mean? It means that one single customer have the interruption of 1.5 hour. Okay, SAFI is given as 3 interruptions per customer. Okay, it means that one single customer is getting 3 interruptions. Okay, so now when you see these two terminologies, one customer is actually getting the 1.5 hours of interruption, and from the SAFI you can see that one customer is getting 3 interruptions in a year. Okay, so the what the SADI shows that uh, one particular interruption was of how much time duration average. Okay, so SADI, when you see SADI through the SADI, when you see, so it means that so single customer is getting 1.5 hours of interruption, one customer is getting 3 interruption. It means that 3 interruptions are there in a 1.5 hour of duration. Okay, so one interruption was of average of how much? 1.5 divided by 3, it is zero point 0.5 hours. Okay, so the SADI was important point is that to see that one single interruption is of how much duration was there. Okay, so this was the one matrix. When you have the SAFI, you can derive SAFI and SADI, you can find out, sorry, not SADI, CAIDI. Okay, so CAIDI, what is the value of that? Is a zero point 0.5 hours. Okay, so the SAFI, we already know that what is the number of interruption in the total number of customers. Then SADI, you got the interruption duration also with the number of interruptions. Then SADI, we've already funded out the how one interruption is of how much hour of duration. Okay, keep this all the three matrices in your head. Okay, let's move forward. Try to solve this through the that definition which we have seen. Okay. Multiplied by 400 divided by- Okay. Okay, I got option B's, multiple option B's. Okay, option B again. Okay, option B. Okay, through that is actually correct. Uh, 1 year 8760 hours. Okay, but our part is not needed here because we already seen that what is the definition of SADI is equal to summation of NIRI divided by summation of NI, number of interruptions. Okay, so this came from the SADI definition and this came from the SAFI definition. Okay, so to remember that is Fi D is already in the first part because C is here, so the D will come into the just to remember C is here, so the D will come into the numerator. So side E will be in the numerator. Okay. When you try to find it out, it will simply 600 multiplied by 1.5 hours and then 400 multiplied by 2 hours, then divided by the summation of Ni. How much number of interruptions will there? So that was 1000. When you try to solve it, it will come out to be 600 multiplied by 1.5 plus 400 multiplied by 2. It will come out to be 1.7 hours. Okay. So let's see the answer, that is 1.7. So here one important point to see that here, this is when you see the NIRI divided by NI, this is kind of average. Okay, how do we find it out the geometric mean? Okay, that is being here the weighted thing is there because the time term is there. So divided by what is the total. Okay, so finding out the what is the average interruption in a year. Okay. That's true. So we three things we have learned: SAFI, SADI, and CADI. Let's move forward. Try to solve this. Easy to relate. Just to confirm that whether you have understand the things or not. Okay, option C I have got. Okay, option C. Okay, option C. Okay, that's true. That's true. Option C is actually correct. When you see here what is being given, total number of interruption is given, total number of interruption duration is given. Okay, so and the total number of customers is given. So in this problem when you see the important part is that key interruption we wanted to know that key SADI basically summation of NIRI divided by summation of NI. Okay, so this is a customer hours which is given already, that is 50,000, and divided by total number of interruption, that is 20,000, so it will come out to be 2.5 hours. That's true. Okay, just remember. Okay, let's move forward to the some new metric to define. Okay, so this is a one more reliability index, so CAFE it is called. So we have seen SAFE, then we have seen SADI, then we have seen CAIDI, then now we are moving forward with the CAIFI CAFE. Try to solve this if you know. Okay, option A, option B, option B. Pankaj, check it again whether it is correct or not. Okay, so I got multiple option B's. Okay, so in this reliability, when you moving forward from these three matrices to the other matrices, last matrix from this to this, when you see here what is written here, total customer interruptions is given 4500, and then it is written a distinct customer interrupted. Okay, that is 1500. What does it mean? It means when you have seen the previous questions, suppose the one interruption came, suppose this is one first interruption came, there 2000 customers got affected for 1.5 hours. Then you got second interruptions in which 4000 customers got affected for 3 hours. Okay, so in this, when you see, it is possible that the total number of customers are nt is given, suppose you have 20,000. Okay, so this, when you make the Venn diagram out of that 20,000, suppose this is 20,000. Okay, so inside you got the first interruption of this, suppose this is the first interruption. Okay, then you got the second interruption. Okay, suppose you got the second interruption like this. Okay, so this is the second interruption. Okay, now when you see the overall Venn diagram in this, so it is, there is a overlapping zone is there. Okay, so this is called as, suppose this is a total set of S, and this is A means ki first interruption, V is the second interruption. Okay, so when you see what is the A union B, A union in B is basically A, uh, when you see subset, or you can say number of A union B is NA plus NB minus N of A intersection of B. Okay, when there is a all the overlapping customers which got affected during the first and the second, if it is equal, it means that there is a no interaction will be there, intersection will be there, so it will become zero in that situation. But when you see that there is a common portion is there in between the both. Okay, and this when you see this part, this is basically nb, number of overall, minus n of A intersection B. Okay, so this is a kind of new customers which is being interrupted, which is distinct from the whatever the in the overlapping zone. Okay, so that which is given here in this reliability matrix, that how much distinct interruptions means the customer interruption will be there. Okay, that is given here is the 1500, and the total customer interruption means overall interruptions, it means that when you see an NA union B is given as 4500. Okay, so you have to see that what are the interruptions were there in the distance consumer customer cases will be there. So in that situation it is basically 4500 divided by 1500. Okay, so it is basically the total customer interruptions divided by CN. Okay, so this is to be quantified that the customers who have experienced interruptions had an average of 3 interruptions per year. Okay, so it means that you have to distinct customer interruptions, you have to, if you have to quantify, which was not there in the substage of the first one. Okay, so this can be quantified in the situation. Okay, so that is basically the CAFE will be simply equal to what it is given here, the summation of total interruptions, summation of NI divided by new customers which was not in the first part of the interruptions will be there. Okay, distinct. Okay, so this is the definition of CAFE. Okay, let's move forward, try to solve this. try to solve this. Okay, option C I got. Okay, option C. Okay, option C. I got one more answer. Let's wait for 10 more seconds and re-verify whether it is correct or not. Just wait for 10 more seconds. After that, I will give you the solution. Okay, let's give the solution. So, when you see understand this problem through the Venn diagram, which already we have seen, suppose there are two interruptions are there. Two interruptions are there. So, this is the total number of customers, and this was the customers which was affected in a first interruption, and this was the second interruptions. Okay, and this is the overlapping zone, means the customers who have experienced the both. Okay, so here we have already seen what was important, that which experienced the single time. Okay, so it means that if it is a if it is a B, it means what it is asking basically. So this is a kind of A intersection B. Okay, so it is asking NA minus N of A intersection B. This was the first customer. Then are asking NB minus N times of A interaction B. Okay, so when you see it is asking this, you have to subtract, when you add this is from the first interruption which was single time, and this was the second which was single time. So it was Na plus Nb minus 2 times of Na intersection B. So what it means? It means that uh, this part basically, this one. Let me take another color. This portion, this got interruptions at a only once, at least once. Okay, and then also you have to add of an A intersection B also. So why? Because these customers which was there in this region, they have also got the interruption two times here. Okay, but you have to consider at least once them. Okay, so in that definition when you have seen, so it will come out to be cafe. Cn was the one single time getting interruptions, and then total interruption of the 5000 to 5000 divided by 2000, it will come out to be 2.5 interruptions per customer. Okay, so now we have seen that what is the multiple reliability interact SAFI, then we have seen SADI, then we have seen SADI, then we have seen here the CAFE. Okay, so these are the four definitions, four performance matrices or reliability metrics we have seen. Okay, now moving forward to the one more reliability index, that is the ASAI. If you know already the definition, try to solve. After that, I will give the solution. This definition is the average supply, or you can say that service also. Is service availability index. Try to solve. Okay, I got one answer. Option B. Let's solve 104 plus. Okay, two answer is option B. Let's wait for also others to solve. 600 multiplied by 2. 0. Okay. Okay. Anyone else? Let's wait for 10 more seconds. After that, I will give the solution. Okay, let me give the solution. So when you see the definition of ASI, ASI definition is basically NT means total number of customers, total number of customer multiplied by 8760 minus summation of NIRI divided by NT multiplied by 8760. Why this definition is there? Let's simplify it. Simplify this definition is equal to 1 minus summation of NIRI divided by NT multiplied by 8760. Okay, let's further simplify with the matrix we already know is equal to 1 minus this we already know. What is this? This is SID divided by 8760. Okay, so by the definition, when you see what it actually telling, okay, so it means that this term, when you see this term is telling that in a year how much hour of interruptions per customer was there. Okay, so you already know in a year how much hour of interruptions were there in a per customer was there. Okay, so if you subtract by the overall system by the one, suppose the overall system considering one, so the time means the frame when where the interruption were there, so we'll get the available time, means available time duration or time frame index in which the it was actually present, the service was available to the customer basically. So in the problem when you see it is saying 400 customer experience the interruption of the 4 hour, and the 600 customer experienced the interruption for the 2 hours. Okay, and the total customer was there 5000. Okay, so when you try to find it out, suppose in the duration, suppose in the year, how much duration means the service was not available. So this was simply summation of NIRI divided by NT multiplied by the hours. Okay, so if you consider, if you try to solve the 400 multiplied by 4 plus 600 multiplied by 2 divided by total number of customer, that is 5000 multiplied by 8760, when you try to solve it will come out to be somewhere some value like 400 multiplied by 4 plus 1200 divided by 5000 divided by 8760, it will come out to be uh, some value suppose. Okay, so if you wanted to find out what's the value of ASAI, suppose I got x value here, so you have to 1 minus x you have to do. Okay, suppose I subtract it by 1 minus like this, so it will come out to be 0.999 something. Okay, so 999. Okay, so you can say that it will equal to 0.93 times 9 is there and further 9 is there, so it will come out to be nearly option B. Okay, so option B is actually correctly matching with that. Okay, so this is a overall duration, it is relating with the SAFI Miss ID, but it is saying that if you have a system, how much available duration it was able to supply the service perfectly. So that is being quantified in terms of the ASAI. Okay, let's move forward and try to some see the one more question on this ASAI. Try to solve this. Okay, I got multiple answers at option C. Okay, let's wait for 10 more seconds. After that, I will give the solution. Okay, let's see the what is the solution is there. So what I have told that ki you have to find out the total interruption actually in a year. Okay, then subtract it by 1, you will get the answer. So ASAI basically the 1 minus summation of NIRI divided by NT multiplied by 8760. Okay, that is correct, Raghav. That is option C is, let's see correct or not. So 1 minus summation of NIRI, it is given 35040. It is already given total construction customer interruption during duration in a year 35040 divided by 10,000 is the total. 10,000 multiplied by 8760. Let's try to solve. It is coming 35040 divided by 10,000 divided by 8760 minus 1. It is coming 0.9996. Okay, so the option C is actually correct. Okay, so what we have seen? We have seen the SAFI, then we have seen SADI, then we have seen CAFI, then we have seen CADI, now we have seen ASAI. Okay, these reliability matrices we have already seen. Okay, let's move forward to a new definition, new kind of reliability matrix, that is called ASAIDA. Okay, you already know the definition, try to solve, otherwise I will give the solution. Okay, option B I got. Option B, one answer. Okay, again one answer. Option B. Okay, option B. Okay, let's see the solution. What is actually the correct solution of this? Correct option B. Okay. So in this problem, it is written that the distribution system supplies total connected load of 500 kVA. During a reporting period, 8,800 kVA load was interrupted for 3 hours and 1200 for the 2 hours. Calculate the ASAIDI. Okay. So when you see the average time frame, it is basically the average only. So when you see ASAIDI, so you have to take the compute the connected kVA duration interruption. So basically here it is written already. We have already seen that 800 multiplied by 3 plus 1200 multiplied by 2 divided by 5,000. Okay, so the unit will come out in the hours. So 800 multiplied by 3 plus 1200 multiplied by 2 divided by 5000, it will come out to be 0.96. Okay, so when you see here, here the one different kind of quantification is there. Here the quantity is there, customer is not there. Okay, suppose when you compare with the SADI, it was definition was summation of NIRI divided by NT. It was given that total number of interruption, duration, and then you have the total customers. Okay, what it was there, number of interruptions, duration of that interruption, and then you have the total number of customers. Okay, but here when you see here, the quantity is given. Quantity means ki, unit wise, that parameter which is affecting the system. Here it is given the loading, basically the connected loading. Okay, so this actually here also ni also n is replaced by the loading basically. Okay, so here the loading term is given. So SADI was replaced if the quantification term of the power quantity, like, so here the ASADI will become summation of ni means summation of load I LI divided by summation of Li, or you can say that ki LT. Okay, so this is the definition. You multiply and you get the you have got the 0.96 hour. Okay, in terms of the loading basically. So the option B is actually correct. Let's move forward, try to solve this. The same kind of problem is there, only the twist in the definition is there. Okay, option C, I got one answer. Okay, C. Okay, that is true. That option C is actually correct. Correct, because we have already seen what is the ASI. Only it is similar to SIDE. Only thing you have to replace it with the loading, not the number of customers. Okay, so ASAIDI will be equal to summation of LI RI or and divided by total number of loading, basically LT. So when you see here the LIRI already given 25,000, you just have to divide by the whatever the total loading is there, 10,000. Okay, so it will come out to be 552. It is coming out to be 2.5 hours. Okay, so the correct option is option C. Okay, so we have seen SAFI, SADI, then CAFI, then after that ASAI, then we have seen ASIDI. Okay, let's move to the new uh, form of reliability matrix, that is called as energy not supplied, means ENS. If you already know the answer, just let me know, and after that I will give the definition and also solution. Okay, I got one answer, option C. Okay, option C. Okay, option C. Okay, that's true. That in this kind of problem, that is very important. That key energy in the duration means key when that interruption was there, then how much energy was not supplied in that duration. Just you have to what you have to do. Uh, ENS, energy not supplied, is simply equal to summation of power which was there during the outage, PI, basically during the interruption time, and then you have to multiply the time of interruption. Okay, so here the 1.5 megawatt is there, so it is multiplied by 2 plus 2 multiplied by 1.5, it is come out to be 6 megawatt hour. Okay, that is correct. So this is a kind of energy not supplies quantification. This is different kind of reliability matrix. Try to solve this. Okay, that we already know that you just we just have to multiply it. Okay, so option C is correct. That's true. So the average loading was 3 megawatt and outage lasting for the 4 hours. The energy was not supplied of 12 megawatt hour. That's true. Let's move forward to a new kind of reliability matrix, that is called as average energy not supplied. Okay, ENS we already know, energy not supplied. Now okay, average energy not supplied. Okay. Mm, option B. Okay. B. Okay. B. That's true. That the option B is actually correct. Okay. So what does it means? You have just have to find out the average ENS, energy not supplied, divided by the NT, no total number of customer. That is called as AENS, average. Okay. So 16 megawatt hour was the total interruption power, and then you got the 8,000 customers. So 2 kilowatt hour energy was not supplied during the interruption to the particular customer. Okay, so the option B is actually correct. Kilowatt hour, no, I think megawatt hour. Okay, so here it will be not 16,000, it's 16,000. Okay, 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 okay. 16 megawatt. Okay, we have to convert it to kilowatt hour. So it will come out to be 16,000 kilowatt hour. Then you will get the 2 kilowatt hour per customer. Okay, so it will be option B. Okay, let's move forward. Try to solve this. Simple. You just have to do the same thing. Okay, that's true. The option B is correct because it will become 36,000 kilowatt hour, and then it is the 12,000 customers. Okay, so it will come out to be 3 kilowatt hour per customer. Okay, the average energy not supplied. Then let's move to the a new kind of reliability matrix, that is the average customer curtailment index, ACCI. Try to solve this. Okay, option B. Yes, that's true. The option B is actually correct. Here, when you compare with the average energy not supplied, this kind of reliability matrix, so there we were taking the summation of PI RI divided by total NT. So here, when you see here, the total utility customers were considered NT. But when you see the ACCI, here the summation of PI RI is there, that is true. But here the number of customers which was affected during the interruption means anti IA is there. So total number of customer affected, that is the CN. Okay. So simply you have to take the 24 megawatt hour is already given, and the 6,000 were affected. So it will come out to be 4 kilowatt hour per customer. Okay. You just have to see the in this you have to take the number of customers which were got affected, not total number of customers. Okay. So the our 4 kilowatt hour is the 4 kilowatt hour per customer is the answer. Try to solve this simple question. That's true. Option B is correct. Okay, that we have already seen. Ki ACCI will be equal to summation of PIRI divided by total number of customer during the interruption. Means ki the customer affected during the interruptions is equal to, so 2 megawatt means you can see the 2000 kilowatt multiplied the 3 hours divided by 3000 customer which was affected during the time, so it will come out to be 2 kilowatt hour per customer. Okay, so the option B is actually correct. Let's move to the one last reliability matrix. Okay, that is a CTADA. Okay, option C, I got one answer. Okay, option C, that's correct. The So, because here it is asking that a customer who have experienced at least one sustained interruption. So, just remember the cafe what we have seen there. You have to change it at least once, not in a common zone. Ki first affected, then the same got the two interruptions. Okay, at least one in a particular interruption is common part, means ki, intersection part. So, in that when you see the hours, so CTAIDI is basically equal to 18,000 customer hours divided by the total affected in that duration. So it will come out to be 4 4 the 16 4 5 20 4.5 hours. Okay, so the option C is actually correct. Okay, 4.5 hours during that. Last problem of this tutorial session, try to solve this. Okay, option B, I got one answer. Okay, B. Okay, option B. That's true. So when you see the B, no? B, okay, 2.4. So when you see that CADI, what is the value of that? So it is basically B, that is true. So that is we already know ki how to calculate that. Ki the customer you have to select in that ki which got the one single interruptions in a particular overall interruptions. Okay, so by that the CTIDI will be calculated. Okay, so option B is actually correct. Okay, so we have seen in this tutorial session the lot of reliability indices and why the reliability is actually important. So that will help you to solve the assignment 5, and there are some more reliability indices are there, but that is not that much important. Just you go through that and let me know in the next tutorial session if you face any problem in that. Okay, that's all for today's tutorial session. Thank you so much for joining. If you have any other doubt, just let me know. Okay, then that's all for today, and we will meet in the next tutorial session. Thank you.